Hello y'all, this is Quirky Python stuff. Today I'm going to showcase wave arrays. Their wave arrays are just arrangement of items in an array. It's just different form of sorting. We have seen 1, 2, 3, 4. This is a list of ascending numbers, and we can just reorder it, and it becomes 4, 3, 2, 1. Ha, reverse sorted and not sorted, like ascending sorted, descending sorted, and then there is just random whatever you can put. But there is one more weird way to arrange arrays just for the show, which is wave arrays. Um, Wave arrays resemble waves, as in highest value, lowest value, like that. Like in reference to two items, higher value, lower value. So let's get a list as in 1, 2, 3, 4, 5. Another list 1, 2, 3, and 4. So here we have 5 elements, here we have 4 elements. So the way array for this will look somehow similar to this. So what we see here, 5 is greatest among all of the items here. Items here. This is smaller than 5 and 4 is greater than 1. So you see, it doesn't resemble this wave particularly, but it does resemble this kind of wave. This is the 5, this is the 1, 4, then 2, then 3. I think I missed, sorry, I didn't miss anything. Yeah, that's just a peek. So you see a wave pattern formed here. Similarly, we can write this as 4, 1, 3, and 2. This looks like a Z. Wait. 2. So this one looks like this. Yeah. 4, 1, 3, 2. So you can see between the two high values there is one low value, like the crest and bottom part of the wave. I don't know what that's called. Crest and a trough. Yeah, the lower valley and the upper mountain. That kind of part of a wave. The 5, 1, 4, 2, 3, and here 4, 1, 3, 2. So how can we go about making this in Python? Okay, so the easiest way I've seen, like I've experimented with, is first of all getting the list. For example, I will take random numbers now, 5, 13, 9, 7. So here we can see there are 4 elements, which means an even amount of elements. So this is one case. There's another case wherein you can have 9, 7 and 17. Here we have odd number of elements. These are randomly sorted or randomly created lists which have even and odd number of elements respectively. And why did I show two different cases? That's because there will be two different ways of creating wave arrays for them. So they will have the first step similar, but the rest of the steps will be a bit different. And I will tell you that why. the first similar step is arranging them in descending order. Like if we see this will become 13, 9, 7 and 5, and this one here becomes 13, oh sorry, 17. Yeah, I forgot there was a 17. 17, 13, then 9, 7, oh, whoa, went off screen, and 5. Hmm. So this is how you will get in descending order. And now what we can keep doing is this is our input list that we have sorted in the descending order. Now I'll clear the space up for a bit and show you the odd case first. Right, the odd case first. So we'll save this for the time. Now we'll see the odd case wherein there are odd number of elements. So what we can do here is, let's say A equals our sorted array, which is this one. I'm not going to write that again. I'll just paste it here. This one. This one is our A array. We can set that to a variable A, which is what we have taken input from the user. And we can set B to an empty array, which consists of only this element, 17. Now this step is also going to be similar in even 1, but I will explain the rest of the steps, which will be quite different. I could have just said that, but anyways, this step is going to be same for even and odd. I just forgot to mention that before. So this is our B array. Now the logic that I have come up with to make a wave array, as in descending wave, is first of all the greatest value, which is 17 here, goes to the first, and then the smaller values, or rather, since we have a descending order array, like 17 is greater than 13 and 13 is greater than 9, we can just swap them. So that will lead to this list becoming, in the next iteration, as 17, 9 and 13. And doing the same thing, we'll swap these elements and it will become 17, 9, 13, 5 and 7. So is this not a wave? Because 17 greater than 9, 9 smaller than 13, 13 greater than 5, 5 smaller than 7. It's a descending wave. So this is the logic, and the same logic with a bit of a twist comes in even. So this is the odd case, and let's see how can we make this into a program. So for, let's say I, because that's patent in Python, for I in range, that's an R, okay, cursive is an R, same as this, for I in range. So as we saw that the first element we have already put in the B list, so there's no point in iterating from the 0th value. We can just iterate from the next value, which is 1. So this is for the odd case. So we can start from 1, and then the length, no, not the length, we are not trying to, I don't know, we can just put the length. Length of A. What is length of A? The length of the input list, the one which we ordered in descending Yeah, ordered in descending order, yes. And then the steps will be two. Okay, the screen does wonky thing when I go at the end. Yeah, so with two steps. Why two steps? Because um you must remember that we are swapping two things. So if we, like for example, if we are at 13 and we want to swap it with 15, when we swap it with 5, then the this, like for example, if i's value is 0 and we swap it with 5, so the next time it becomes 5 and 13, and when we are again going to swap it with here, there's nothing here, so null pointer exception can occur. So instead of doing that, we can just jump from 13 to the next value, and we'll hope there will be another element. And if there's no element, we know that in Python, if there's no element, it just stops the loop. So we can use that feature. So we'll have the two steps. Yeah, two steps. Now within this loop, we'll do the swapping thing. So we can just write b dot insert. We did here was say the 9, which was right here, we said that to go here, and this one to go here, which is like, if I can write that again, 9. So I value was 1 and this was 2. This is the index values and these are the real face values. And what we did, b dot insert I, which was this position of b list, what is in a second, like this, I is 1, so I plus 1 is 2. In the second position, which is 9, we put in the first position, and the same thing we did, just the opposite thing. The I value in B's I plus 2 value, I plus 1 value, which is 2 in this case. So this is what we iterated for the first time, and the next time we do it, what the and the next iteration that will happen is when the these two values will remain constant, and the next iteration happens like this: 1 2. Like obviously it's not going to be 1 and 2, but for simplicity I'm just saying 1, which is this now, like for this is the fourth. Okay, I will just write it in terms of indexes, it will be way easier to explain and understand. 4 Java. So and writing's gone bad, never was good. Whatever. So this is the fourth index, 0 1 2 3 and 4. So for the third position, third position of B list, we'll put what's in the fourth position, so which is 5, and the same thing 7. What it does after, like, why did we put two steps is we are here now and the next step will go here. If we just put this loop twice, there will be errors in this situation. And next iteration, what we will do is sorted. If we swap them, the first one's going to go all right. Right, the first situation will go all right. We'll just have 9. Like, okay, let's copy 13. 13 is going to be here. 9 is going to be here. And 7 is going to be right in the middle. Okay, I can't place that like that. 7 is going to be here. 9 is going to be here. This is perfect, you might say. But what about this one? What about when we come here? Is there any value which we can swap with 5? Because it's the last item, right? So there is null pointer exception, and for the third iteration, for the third iteration you will get null pointer exception. I don't think that's what it is called in Python. Probably they'll just say index out of bounds exception. Whatever. They'll just give you an error. Null pointer is in Java. Probably it's in both. So this is what will happen. So instead of that, we can just do it from second. So if we from here, then we can swap them. But now you must have noticed something. Probably some error. I mean, I didn't recognize this at first, but probably you can, which is the fact that we are starting from the second, right? Starting from the second position, which is right here. We have completely ignored this one, the 9 one. So we actually won't get this. We'll simply get 7 and 5 here, which means we have altered the list, and actually this is not the list we asked for. So our wave has been created. Our wave has been created, but in the wrong way. It definitely became a wave with 5 lesser than 7, 13, okay, and 7 greater than 5, but not the one which we wanted, right? And in the next iteration it just won't give anything because the loop ends, as is the end of the array. There's an easy fix for that. We can simply just append, like b dot append. At the end of the loop we can just write b dot append. Okay, and what is the value? A dot 1 to the list. We would get the answer as final answer as 13, 5, 7, 9. So that's a wave. But what if you don't want to do this? This is a small hack to get the right answer, which you can do, but there's an easier way. There's a better way. Not easy, a better way to do this, which is just swap our logic. We'll snap out of our logic and create a new one. The result will be vastly different. Instead of b dot insert I in this, what we can do, since we are starting from the second position, which is right here, we cannot swap between these two. Instead, we can swap I between these two, since we are starting from second position. So we can just write, instead of I, we can just write I minus 1, which is like, since we have 2, we'll put I, which is 13. 2 minus 1 is the first position here. What we will put in there is simply I, ith index of A. So what is the second index in this case? It's 7. 7 here. In the next line, you can just write the complete opposite, the thing that we did previously. I, and here I minus 1. Oh god, you got, it's barely visible. I minus 1. Sheesh, handwriting real bad. So what we will get here is, with in the ith position, which is 2, we'll get what is in I minus 1, which is this one, 9. So here, and if we go do the same thing for this, if we do the same thing, what? Where is an error that can come up? Wait. Yeah, so there won't be an error, sorry. There won't be an error. The only thing will be that the 5 has to swap with something which is null, and we are ending the list at null, so it just does this. Yeah, like there's nothing, like after 7 you're straight going to null and you're swapping between them. So what you're doing is creating a fifth null, like fifth value which is null, and we're swapping the null value with 5. As you saw in the previous one, it does nothing, just puts 5 here. That we don't get any error since Python does it for us, helps us a bit, and what we get is our result. Let's program that. Try that again. Yeah, so this is for our odd, like the odd list. 56, the higher value, lesser value, then a bit higher value, then a lesser value, then a bit higher value. So wave's been created, a descending wave. Now let's try for the um, even one. Is this even? This is even. Come on. Let's try for the even one now. Here we got our list. 56, 34, 37, 5. Yeah. Now, as what I had thought about the experiment, this value, if this is null, right? I thought if we swap 5 with null, we'll get null over here and 5. And since a list cannot possibly have a null value, it would delete that null space and put the 5 there, thereby creating a 4 lengthed list. The logic was weird, and I was also confused at first that how could I come up with this experimentation. But I thought, let's give it a try, and it didn't work. So, yes, this is the only way. B dot append. At the end, you just have to append the last one, which was lost. So, this is it, wave array. And thanks for watching. I'll find more quirky Python stuff. Until next time, bye.